Welcome, welcome, welcome. My name's Blades, and yep, today we're going to be doing episode 6. I'm going to be talking about OpenGL today. But first of all, that model that we made, I had a quick look at the MTL file, and it's got a couple of things in here that, KENNI. Yeah, right, well that's interesting. What are them? Yes, what are them? So let's go and have a look at our data structure and find out. So after specular highlight component in our materials, I've changed also where the MTL file break marker was. It was further up before, but I've brought it down now to where the MTL file actually is here. These are all items from the .obj file. I'm just an idiot where I put me breakers sometimes. So let's get these two sorted out. Yeah, okay, so we'll knock the to-do off like that. Give it a bit of space. And all we have to do now is obviously put in the structs for these because we don't have them. So struct, and the first one is Emissive Coefficient. There you go. Yeah. I've got to put the notes in to tell me what it is, because I would never have known. How much light is... Why has that gone yellow? Oh, that's right. Make it all one word. Emissive coefficient. Yeah. What does that mean? It means how much light is coming out of the object. If you want to do a light bulb, for instance, you actually have to tell it how much light is coming out of the object. Lampshades as well. Things like that. So it's rather important, and it wasn't on the wiki. Oh, thank you, wiki. Obviously not up to date. What is an emissive coefficient? It is KE. KE is 3 floats. So it's float, red, it's an RGB one, isn't it? So it's one of these. Copy and paste. Copy and paste. I forgot that bit. Duh. There we go. So it's float, M red, M green, M blue. Emissive coefficient, red, green, blue. M green, M red, yeah, blue, blue, blue. Yeah, that's lovely. Thank you for that. And the other one we had was NI. NI, refraction index. A value of 1 will cause no refraction. I'm not certain about other values. What I read said if as increases, the refractive index increases. What we're talking about here is glass. How light bends through glass. I'm not sure how refractive indexes should be used, if at all. So I'm going to put it in anyway because it's there to be put in. So give ourselves a bit of space here for a struct. Yeah, and this one is going to be refraction index. Yeah, Moppy, you're in the way a little bit there. So, refraction index, here we go. Let's pop you in, and it's just a float. We'll just call it M underscore refrac index, semicolon, couple of spaces, copy, paste, open, and it's just a float. Nothing fantastic, but we've still got to add this kind of thing, because if we don't, well, we're not going to be able to read it, are we? Simple as. So let's do it properly. M_refraction index, refraction index, and then a couple of squigglies. There we go. So just a couple of extra structs in case you wanted them or needed them. You know, it's one of those things. So, oops, there was a to-do left in there. Just take the to-do off. Done it. So that's what that was. And that's what that was. The other thing that I did notice was back on my faces. Well, I thought about it and I thought about it and I thought about it. Because of what this says, we can have that, or that. So, yeah. And not really setting any kind of base, the vertex we need. We're still going to be passing the values, but we now need more than is quad. We also are going to need M has textures, because it's not a given. We can't assume that it has, so we're going to have to be told. Has normals. There we go. So we're going to have to put those values in, and I'm going to extend this so that we have a bool is quad. Yeah, because it's going to be fully automated. I've decided we're going to be passing in all of these values, but it's all going to be done automatically. The whole system that we're doing here is going to be fully automated. Yeah. I'll show you how. So, you should do the same with what we're going on to next. We're going on to shaders next, so we should really be thinking about doing the same with the shaders. Shaders should be generated more on the fly than as definites, but I mean that's real like game breaking stuff. Has normals. Yeah, put an M in front of it as well. Oh no, you don't. Sorry. Whoops. Thinking ahead of myself. So, has textures and has normals has been introduced, which means down here at the bottom, no longer there equals that. It is quad. Yeah, that's right. M is quad. Yeah. So M underscore has texture should equal has texture. Or textures, sorry, I'm pluralizing again, and that's a bad habit of mine. I shouldn't, but in this case it's okay because they are plural. Has normals, or has beans. Don't look at me. Does it have normals? Yeah, of course. There we are. So the only thing we can guarantee really is the vertexes, because it has to have vertexes, no matter what, or vertices, should I say. It's got to have vertices. So there we go, that's another to do off our list. There we go, and if I get my tasks list up, okay, just, can I delete that? open this. Oh God, will you stop putting things on it? I'll work that out later. It was just as a reminder to me. I put a marker in for that. I think we're done. So let's talk about OpenGL. What do we need to do about OpenGL? Save this out and get rid of it. Well, let's. OpenGL is all about the graphics card. So under, let's get out development mode now, and let's put in a new, add new folder. I notice we don't have source here, so we'll put source in, and it's just going to be src. I noticed that Microsoft Visual Studios, whilst I was going through a load of the options, it actually looks for that. That's why I'm not putting it in full. I should really put source, but I'm not sure how it'll deal with that. So what I'm going to do now is add a new folder in here, and I'm going to call it GFX card for graphics card. And what we're going to do in here is program a graphics card. So add a new item. We'll just start with a header file, and I'm going to call it GFX for now, because I'm not sure what to call it. I'm not sure at all. So we'll add that. And we'll separate you off. Namespace it. And it's model. 3D, is it? No, it's just model. Check. Double check. Yeah, we've just used model, haven't we? Yeah, we have. Okay, that's double checked. Save. Alright, let's get a function going. Or something. Shaders. Programs that run on your graphics card are shaders. So if we look at our overall model here, we've got our structs, we've got our read file, we've got our vector storage. Okay, well, they're not complete, they're still in development. That's fine. As an API, well, we can't do that until we know what OpenGL is going to need. So this OpenGL VAO is what we're looking at here. And all of that is here. So what we need to look at is VAO and shaders. There's two shaders. There's what that we're going to look at. There's a vertex shader and a fragment shader. The vertex runs once per vertex that we give it, and the fragment runs once per possible pixel or fragment that may be placed on the screen. If a fragment lies behind something, the fragment is thrown away because it's not going to be seen. So that's what the fragment shader is all about. That chooses which fragments are going to become pixels, and that can run thousands of times per vertex. So when we code these, it is obviously more efficient to put code in the vertex rather than the fragment shader. So it's something to consider whilst you're doing these kind of things. From the previous exploration of C++ and stuff that I did, we actually have all of this information already. So it's not honestly too bad. Qt is rather nice. So let's look at those shaders. First of all, doing bottom to top as usual with me. So let's pop that back up here, out of the way. So what we're going to include, shall we make it a class? No, we're not going to make it a class. What I'm going to do is I'm just going to run a few bits and pieces in here, I think. Let's construct some functions first of all. So the first one we're going to do, or the first function that we are going to do, is going to return our shader program identification. So that will be an int, I think. So the program is going to be, it's going to be a QGL shader program. Okay. So let's start with that as an include. Hash include. And it's Q OpenGL, is it? Open, oh god, yes. And we haven't got anything. Which means we need to look it up. And I haven't opened my looker upper. Here we go. That's okay, let's pop that up on screen here. It's going to be off the bottom. So search Q OpenGL shader, and it's going to be program. There it is. Qt plus GUI. Okay, I think we took GUI out, didn't we? That's why. Okay, that's what I wanted to know. So in our profile, which isn't using app bundle, yeah, it took it out. God, I wish it hadn't. So delete that line. Doesn't matter, just delete it. Which does mean we don't have GUI or GUI. How are we going to enter that then? Let's have a look. Properties. Linker. Header files will be alright. But in here, we're not alright. I better check header files actually. Additional include directories. Edit. Generated files. Qt include Qt core. Right, okay. Is there a Qt GUI? That's an interesting thought, isn't it? MSVC, that one please. And includes Qt. Yeah, there is Qt GUI. So we'll pop that on. So there. I'm just going to add dollar QTDIR, and then it's backslash include. Is that right? Yeah. Include, and then backslash QT, and it's capital GUI. Okay, we'll have you. So general over here. What do we need here? Libs. I just thought of something. There's an easy way of doing this. I can just do... This goes up off your screen, I know, but it's okay. I think it's a solution directory, is it? Update, I release, and I update. No. How do I update the solution? We can't, I don't think. Okay, under Model 3D, right click, and near the bottom where it says, well, it's just a few above rename here, it says Qt Project Settings. I open that, and in here, I should be able to click on GUI. Like that. We've got core, now we've got GUI. I'm not putting OpenGL in because I'm not using that. Or am I? Two ways of looking at this one. We'll see. We'll see. I think it's just GUI. I don't want widgets. Okay, that was the thing I didn't want to go through. Okay, so we've done that. So now I should be able to do Q open. Q open. This is better. OpenGL shader, was it? Shader program, yeah, shader program. Lovely. It did come up now. That's, oh no, you've done it to me again. Stop altering it. Now I've got to go through and put all my capitals back. Thank you, that's what I wanted to say. I don't want to have .h's on the end. So that means we can now have a Q open GL shader. Why is it? Oh, there we go. Shader program to couple down. There we go. Do I need a reference, or can I just pass back the OpenGL shader? Well, isn't that just an int? This is going to be interesting. Okay. I'll leave that as it is for now. We're just creating stuff, actually. Create shader. Don't care. Right, okay. So what I want to do is create a shader and then pass the shader program back to whoever called it. So what I'm going to do is say, give me a shader, and it will create shaders. So actually it's plural again. Create shaders, because it's going to be creating a few. So how does this go? It starts usually with a program, and that will be that thing there. It is going to be a star. Thought as much. So I've just thought through the next line. And it's going to be star program, isn't it? Star program equals a new one of those big long lettery things. And that should do it. Do I need brackets on the end? I'm not going to put brackets on because I can. Why not? So, QOpenGL shader program. Star program, because we don't want to keep it in chip memory. We want this to all be done somewhere else in our memory, away from the CPU. Don't want to clog up the memories. So, that's what we've got. And it's very, very simple, really. in Qt to make a shader program. All you have to do is take the program, and then it doesn't change it to a dot, does it? Okay, add shader from source file. That's that one. Oh, it has gone to an arrow. Good. It does it automatically for me. That's good then. And that's going to be a Q OpenGL shader, which we don't have. So what we're going to do here is hash include the next part, which is that. What happened there? Copy. Control V. There we go. And that's going to be a paste. And we will need the vertex, please. Are you going to tell us that we can have a vertex? No. What's wrong with Q OpenGL shader? Oh, who cares? Comma. And we will take the basic. We'll just write a basic one for now. Dot vert. There we go. Semicolon. That's not an error. Must be a class. Well, yeah, it is. What's wrong with you? Yeah, Q OpenGL. Is that all it does? So that's really not needed. So why can't you find that? Okay. Q open. Q open. GL shader. Span. Oh, no, you can do it, can you? Okay. It does now tell me it doesn't like vertex. That's probably because it's got a capital V. Vertex. There we go. We've now finally done it. So you don't really need that. I never saw that before. Fine. I don't care. There we go. I'll have that again, please. From program add shader, and this time it's just fragment, isn't it? And it's going to be frag at the end. There we go. That's those two. So you get your two files off your hard drive or wherever you've got them. We will need to add those in a second. So you read them in, and then Qt does the rest. So we just do program, and we link it, and then it's program, and then we bind it. Which really we don't need to do, I suppose. What we do need to do, though, is reserve our attributes. So let's have position, color, and well, I'm just going to be copying out the one that we've used in the previous episode, I think. I think we're just going to use those again. So we would need to store Yeah, I'm going to put that to avoid, because that's no good really. What that means is, get off me, got to put M on these, because we're going to obviously have to keep them. There we go. Putting M's on things. I don't know. Make them members of something, whatever I'm writing here. And then we can just pick them up from here easily. Because here I want to have a position, which is going to be our vertex. I didn't call it position in there, I called it vertex, didn't I? Oh well, never mind. Just thinking about going backwards. I'm just thinking backwards about what we've done before. That's going to be M underscore program now. And we will be... I always put a dot in, by the way. It's automatic. And it's that one. And it'll change it to an arrow anyway, because it's supposed to be an arrow, because it's a pointer. It's a memory address. So what I'm saying is the memory address of the pointer. Could you please then tell me what the attribute location of position is from that address? And we're just going to put position in here. Yep, it's looking good. Will we need another? Oh, it doesn't know what M position is. It's an int, isn't it? If I remember right. I think it is. There you go. Got to do that for now, but hey ho. Why don't you like pointing at bind? Oh, I don't want bind, I just wanted attribute location. I want to bind it. I don't know. Small a. There we go. Next is int M underscore color. Spelt the American way. Oh well. M underscore program. And it's then going to be attrib location. And that's going to be color. There we go. That's that one done. And we'll also need an extra one. M underscore MVP. Again, I think it's an int. Don't know at this stage. We'll work that out later. Equals M program. You see, it gives us everything. There's no messing about. It's really fantastic. This one's going to be a uniform location, because I'm going to be using a uniform. Uniforms happen once per draw call, whereas the other ones can vary throughout the draw call, because you're going to be using lots of positions, lots of colours, but you're only going to be using one MVP model. MVP model something projection. I'll come back to it'll come back to me. Just bear with me. And that is going to be EU underscore MVP. It's the matrix, the model view projection matrix. That's what it is. Thank you, brain. We should be able to keep up with me typing and use my brain at the same time. That's it. Yeah, that creates the shaders. All we need then is under resources, and we'll call it add new folder, shaders, capital, yeah. In here we're going to add a new item. It's HLSL, it calls it in here for some reason, and they don't have them. here. Graphics. Test. No. Data. No. 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 Okay. I'll do that then. You know, it's just what are you, yeah, what? It's just a file. That'll do. So we're going to call the first one basic dot frag. No, vert. Do that one first. Basic dot vert. I can't see the dot there. Why can't I see that? Because I haven't got my glasses on. Just one sec. Yes, I did put 2 dots there. There we go, basic.vert. You see, it'll do it. It's just stupid about it. And it isn't pragma once. Nope, it's hash version. And we'll be using 330, thank you. This has GLSL built into it. Or should have. But it doesn't matter. Not really, I don't think. It's annoying. That's all it is. It's just annoying. So I'll use 330 core because I'm not going to get highlighting now. Layout. So the layout location equals 0. Spaces don't really matter, it's just tidiness. Vec4, and that will have position. Now you know why I put Vec4 in there, because you now know that it can have 4, an X, Y, Z and a possible W. So yes, you now know why. Layout, location will equal to 1. In Vec4, again, we're going to use color because we do want the alpha channel. That'll do that. We'll need the uniform. Get this microphone back towards me does help. Uniform. Map 4. Matrix 4. I also start uniforms with a U, and then it's MVP. Semicolon. And we are going to send out to the fragment shader our Vec4, and it's coming from here, from the vertex shader, so I am going to put a V in front of it to tell me where it's come from. Color. Looks good. Void C, it's not C++, so I've got to be more careful. Main. Yeah, okay, we'll put the void in. You don't have to, really, but we will. Okay. We'll have GL, capital position, equals EU underscore MVP, and that's multiplied by position. There we go. Yep, simple as that. And V color, we're just going to pass the color through. Equals color. We're not going to do anything with that for a sec. We'll just leave it as is. I think that's going to be the best idea. And that's saved. Add another one. And this one is going to be called basic dot frag. There we go. And that is just going to be a version. 330 core. That's just a version of OpenGL that I'm using. I'm choose that version because it's the most basic modern one there is. Everything else has been built from there. So this will give us the base commands. Nothing flashy going on here, so nothing to worry about. And this is a very, very simple in Vec 4, and it's coming from the vertex shader, and that's going to be color. Not going to do anything with it, so it's just going to be void main void because we can. No, I better just press caps lock, didn't I? Okay, so GL frag. Yeah, we're alright there. GL frag. Color equals. We're not going to do anything. Just keeping it bog standard. Very, very, very simple. There we go. And all we need to do here is put resources. I prefer using forward slashes. Doesn't matter, I don't think. Not these days. Shaders. Forward slash basic. There we go. There we are. And that should pick up where the shaders are. Again, it might not. Hopefully it will. It'll give us an error if there's an error. It's Qt. It'll be fine. Right. So that's the kind of thing we're looking for there. So that's your shaders. That's the whole code that we need for these shaders here. So that's covered. Now we need the VAO. And what is a VAO? It's a vertex attribute object. And there you saw us doing attributes. So attribute locations. So position is our going to be buffer 1 because that's what was said in the basic frag, and color is going to be buffer 2 of the VAO, as that's what was said in the frag. And the vert gets the color from the vert, sorry, that's what we said in the vert. We've put the attributes position and color. Color gets passed through to the frag, so we don't need to worry about it. And there is a uniform location, which will be passed through separately. It doesn't come through the VAO buffers at all. Yeah, neat. So that will be set by itself. So what we're looking at then is a VAO, and then attribute location 1, attribute location 2. That's coming in separate. So all we need is position and color. Per face. Oh, God, I remember that face code. Yes, we just quickly looked at it before at the beginning of this. So yeah, this is going to start getting a bit more complicated now, because what we're going to do is we're going to just write some code. We're going to call it void create, and it's VAO. Nothing special there. So we're going to create a vertex array object next. Now, if you want to get more comfortable with vertex array objects, I'm going to give you a chance to look it up yourself. And before you do look it up though, get a picture in your mind of a menu card from, let's have a look, any cafe, any restaurant, a restaurant menu. And at the top it says menu, and then it says item 1 and what it contains, item 2 what it contains, in other words buffer 1, buffer 2, buffer 3. So it's a bit like that. It's like a menu card, and this menu to make a model is held on our graphics card, which is why I did this graphics card. So it's like a menu for making a model. That's a good way of thinking about it. So bear that in mind. I'm going to give you a chance to look it up. I'll do that in the next episode. I have been working on the faces, as you can tell. I've now got it nearly finished, how to do the faces. So yeah, it's actually got quite a few ifs in it, like if we have textures. Yeah, I haven't even finished. It's most likely in English, all of this. Most of it is. So yeah, I've been working that code out. Bits of it's still in English, but hey ho, when we actually write it up, I'll turn it into code. And I think that's, once we've got those faces, we're going to have to make sure we have the chance to do normals and textures. So we'll add that to our store object part. We need to add starts with whatever. I think it's VN for normals, T for textures maybe, I don't know, but we'll find out. We'll work through it, and we'll get all of these storages sorted out. So we're only going to have 3 storages and the faces to start off with, to do a basic run through and load the model up in a basic way. Even though we've got lots and lots of information available to us, we'll be cherry picking a little bit of the information. So it's going to be interesting. We can do that. Lovely. In the meantime, I would like you all to take care out there. And if you're not having fun by now, you certainly should be. Take care.